Okay, can you see my screen?
I can see you.
Okay, great. But can you see my presentation?
No, not yet. If you go to the bottom, can you see the green?
Share?
Yeah.
Okay, cool.
And that'll come up. It should come up.
Okay.
Yep. Perfect.
Okay, great. Okay, so as Chris said, I work for Buro Happold Engineering. So I'm going to tell you a bit about what I do, what my job is. But first, I'm going to start with what a structural engineer actually is and what they do. And then at the end, I'll just say a bit about how you can get into it if you want to. So first, what is a structural engineer? Well, to understand what a structural engineer does, we might want to think about what a structure is. So in fact, a structure is anything that stands up. So anything that resists a force, whether it's gravity, whether it's wind, whether it's water, anything that tries to push something over, if it gets resisted by structure, then we can call that structure. So for example, a wind turbine obviously has a lot of wind force trying to blow it over. So we have to make sure we design it so it's strong enough to stand up. Buildings have the wind force, but they've also got all of us in them. So you might be sat in your classroom now. So there's you, there's your desks. The structure needs to hold everything up and stop it falling down. But structural engineering isn't just buildings and wind turbines. It applies to everything around you. So the chair you're sitting on or the floor you're sitting on, somebody's thought about how that works so that you don't just fall through it. And the same with the planes. If you've been on a plane, how does the plane resist all the forces on it when it's going so fast? And the same with cars. So how does a structural engineer do that with a building, for example? Because I work in buildings. Well, the analogy that I find it quite helpful to use is if you think of your body. So in your body, you've got your skeleton, and that helps you to stand up. So that's what the structural engineer is in charge of designing. So if I was designing the body, I would be looking at where I wanted to put the bones and how big I wanted to make them to make sure that you could still move how you wanted, but so you don't fall over. The architect, they'll want to look at how the body looks. So they'll try and make it pretty. They might dress you up. They might decide what form they want it. So they've decided they want 2 arms and 2 legs. The mechanical engineer wants to make sure that everything's functioning right. So all the different blood vessels, all the heart, all the pumps, and all the cables and vessels to get all those services out. So in a building, that'll be things like air conditioning, and that'll be things like drainage. So when you go to the bathroom, where does your water go? Well, the mechanical engineer wants to make sure they get that water and take it to the sewer so it can go and be treated. The electrical engineer, if we look at the body, they would be the one designing the nerves. So they're sending the signals around the body to make sure all the different parts know what they need to do and when. So in a building, that would be all the different wires. So if you want the light to switch on, you can press a switch and there's a cable that runs to the light bulb and the light bulb turns on. And then the quantity surveyor takes all of this and puts it on the scales and makes sure it weighs about the right amount. So it's not too fat, which is if it's too expensive, and it's not too thin, which is if it doesn't cost enough, because that means it probably isn't good enough. So if we apply that to a building, then the structural engineer, for example, on this building, will be trying to decide what frame to use. So you can see there's lots of triangles here. So that's a good strong shape we like. So we've decided because this building's so big and complicated, we'll try and get lots of triangles in there to make it stand up. So if that's what the engineer does, what does the architect do? Well, you might have heard a bit more about architects before and that they design buildings. But what does that actually mean? Well, it means that they're trying to decide what shape the building is going to be and where all the different rooms are going to be in relation to each other. So in your school, they might decide where's the big hall going to go? And that might often go right in the middle of the building, because then all of the classrooms aren't too far away from it. And where might the toilets go? They might make sure there's some toilets, say 1 block of toilets for every 4 classrooms. So there's enough toilets for everyone. So the architect wants to think about how the building is going to feel, how it's going to look, and how people are going to use it. Whereas the engineer, in particular the structural engineer, wants to make sure the building can stand up. so it doesn't fall down, because that's obviously pretty important. So there's lots of different forces that might act on a building. So there's gravity. So when you jump in the air, you'll pull back down to earth. And it's the same everywhere. The earth wants to pull us towards it. But if you're 4 floors up in a building, the building needs to make sure that that doesn't happen. So it needs to resist gravity. If the wind blows on the building, you want to make sure that we don't blow away like a leaf. And then also in other countries where there's earthquakes, we want to make sure the building can resist an earthquake, shaking it. And then we also want to think about, if it gets really hot, that doesn't cause problems either. So it's not just structural engineers and architects that work on buildings. There are all sorts of other engineers. So I've mentioned a few. So we've got the electrical engineers and the mechanical engineers, but there's also lots of different ones. So for example, geotechnical engineers, they look at foundations. So how do we get the loads from the building into the ground? Civil engineers look at big projects like railways, like bridges, trying to connect all the different infrastructure together. So where do all the drains go? The civil engineers coordinate all that. Water engineers look at flooding and how we can plan and landscape buildings and cities to make sure that we minimize the risk of flooding. And then there's all sorts of other ones that work with different bits of the building. And all of this are types of engineer that uses maths and science to solve everyday problems to make sure that buildings get designed and can stand up. So what's my job? Well, I thought I'd tell you a bit about the different experiences I've had while I've been working, to give you an idea of the different range of things you can be involved in and how wide engineering is. So when I was at university, I worked on a project in El Salvador, which is quite a small country in Central America. So there, it's very hot and there's a lot of earthquakes. So I worked with the charity who were designing a building that they wanted to be as cheap as possible so that local people could afford it. They wanted to use local materials so it's sustainable, and they needed it to be seismically resistant, so be able to withstand earthquakes, because that's a big problem in the area. So they came up with this housing design, and I wanted to test whether the walls actually could stand up to earthquakes. So I looked at what the walls were designed out of, which if you look on the left, so they're made of bamboo canes, and then they've got some cement on either side, and there's some wire mesh, a bit like used in the garden, within the cement, because that holds the cement onto the panel a bit better. And then all of that sits in a timber frame. So I had to make the wall panels, and then I designed a test to basically shake them a lot and see what happened. So the middle picture shows the test apparatus that I built. So a really good thing about engineering is you can take your maths and science, but then you can have a go at building stuff and seeing whether it actually works how you think it's going to. So that's the frame I designed, and then having shaken it, got lots of different results out, but you can see on the right that how this panel failed. So the fact that we had that mesh, like I said, within the cement, which is a bit like you have in the garden, when the panel shakes a lot, you can see the mesh actually prevents the cement falling completely off the panel. So if that was in your house, then it would mean that the cement, rather than falling on your head, would actually be kept on the wall, so you'd be safer. So that's a really good thing. So then I started work. So I work for a company called Buro Happold, as I said. We do all sorts of different structures. So we work in buildings, and we also do city design. So these are just a few of the buildings we've done. So we worked on the Millennium Dome, which is now the O2 Arena. So that's a massive tent in London, right in the centre of London. So there's lots of different problems, like how do we get things to site? There was old buildings on the site that had to be knocked down. There's also the river nearby, and there's a tunnel running under. So there's lots of different challenges we have to think about, and all different problems we have to solve to try and be able to make our structure happen. And then the one underneath that is the British Museum. So again, in London. So the British Museum is quite an old building. So you can see it's made out of stone on the left, but they wanted to put a new building and a new roof on the courtyard. So we looked at how we could span across onto an existing building without damaging it. So we decided to use this lightweight steel frame and glass, because then lots of light still comes in. And then the building on the right is in Macau. So that's a tall building of probably 30 stories, and the architect wanted it to, wanted the public to really be able to see the structure. So normally the structure is hidden away inside, but in this building they want to put on the outside. So you can see, like I said, we use lots of triangles to try and span up the building, as triangles are a strong shape. So then I went and worked in Tanzania for 3 months. So this is a different type of project. So I was working in an informal settlement. So that's where poor people live. So in Tanzania, not many people have toilets, and if they do, they're just basically a hole in the ground. So that's really, really dangerous, because people can get ill from different diseases that are either carried by the water, such as cholera, or they can get diseases that are transmitted by mosquitoes, which like water, such as malaria. So we went there and we worked with the local government and local people to try and come up with a solution to this problem. So we implemented a system which, like we have in England, where we have toilets that are connected to pipes that take the wastewater off to a treatment works. We started trying to implement a more basic version of that. So you can see the toilet behind me, and that discharges into the little junction box. So the wastewater is taken out of the toilet, and it's taken down the pipe to be treated. So there's not a lot of water, just wastewater just standing around in the toilet or near people's houses. And this was 4 years ago, and already there's a lot less disease in the area. So that's just another example of how engineering can impact a community. So then day to day, I am mainly office based, so designing how things are going to stand up, so how big different columns and floors are going to be, and where we're going to put them to make sure the building stands up. But sometimes we get the chance to go to site and see the project being built and make sure that the builders are building it correctly. So one of the projects I worked on was the new Tottenham Stadium. So you can see on the left, that was the design that I did in the computer. So we've got lots of different slanting elements, which are called rakers, and they support the seats. And then on the right, you can see when I was on site watching it to make sure it's being built right, you can see actually it comes to life, and it's pretty amazing to be able to see something you've designed actually be built, and especially such a big scale that'll have lots of people on it. Another project, completely other end of the size scale, was a sculpture or a puppet that I helped design. So this was for use in Cornwall. So they were celebrating the anniversary of the Cornish mines becoming a UNESCO World Heritage Site, and they wanted this puppet to be able to go around Cornwall on a lorry and then stand up and do demonstrations in town. So again, we had to make sure that it could take the load, so all the weight of the different parts, and also that the wind wasn't going to push it over. And because it was a puppet, then the people, as you can see with the wires, needed to be able to move it and control it. So that creates other loads that we need to think about. So on the left, you can see really simple bit of analysis I did, just looking at when the weight of the puppet acts, will that try and tip over the digger? Because you can kind of see if it's really heavy on the front of the digger will tip over. So just checking that the digger wouldn't tip over, because if it did, then the puppet wouldn't be allowed to go around Cornwall. And then another project I've worked on is in Rwanda. So in poor countries, often they can't afford to build bridges over rivers. So when they flood, it can be really difficult to get to the other side, and you might need to get across to go to school or to go to the market or to go to hospital, all the things we take for granted because we have so many bridges in England. So there's a charity called Bridges to Prosperity, which work with different companies and universities to go to different countries and help the local people to build a bridge. So I went to Rwanda, and we built a bridge that was 60 meters long over this river in Gaziza. So this is a really good example of, again, being able to go to site and actually be able to build something that you've designed and help people solve everyday challenges. So that's just one example of what engineering offers. So there's different ways to get into engineering. It's quite a few different options. So you're all at school at the moment. That's a good start, as everyone hopefully is in the country. So you then all have to do GCSEs, and then after GCSEs, you can either do A levels or you can go straight into an apprenticeship. And if you go into an apprenticeship, you can then work on the job. So you can learn what engineering is, but you can still study at the same time. And then that can lead into a career in engineering. Or you can do your A levels. So maths and science are really good things to focus on. And then you can go to university and learn about engineering there, and then you can go into work. So there's different ways of doing it. And then once so once you've done that, you're in industry. So then you can work towards a professional qualification that shows you're a good engineer. So I've recently become chartered, which is a bit like being a lawyer or a doctor or an accountant. It shows you're a certain level, and then people know that you know how to do your job, basically. So how I did it was, at school, I really liked maths and science and art. So I did a few GCSEs, but art was included. I also did other things. So I liked languages. So I did French and Spanish and things. And then I decided to do A levels. So you can see I did very sciencey A levels. So I did maths and science at A level. And then I did general engineering at university. So tried all the different types of engineering out, and then decided to choose one to specialise in. And whilst I was at uni, I tried different jobs over the summer to see what I liked and didn't like. So one year, I also got the chance to go to China. So I helped to teach children there what engineering was and help them with their English. So hopefully you can see how many different opportunities engineering offers. I know for me, it's been really rewarding. It's just so great to be able to solve problems and then see your design come to life. And also, engineering is all around the world, so it's given me the chance to go to some amazing places that I know I wouldn't have if I wasn't doing engineering. So yeah, that's it. I'm just gonna plug the charger in because I think my laptop's about to die. But yeah, do you have any questions? Do you want to type them in the chat, I guess?
Oh, that's great. Thanks, Ellie. Well, that was wonderful. So, for teachers, if you have any questions for Ellie, or more importantly, your pupils too, if you could type them into the chat facility, please. If you go to the bottom of the screen for the people who don't know, put your cursor to the bottom of the screen. The little menu will pop up, and you'll see chat. Press on that, and then just type in your. Oh, and here they come. Type in your question. Ellie, can I ask you to come out of share screen so your full face on the
Yeah, how do I do that?
Again, if you go to the top of the screen, you'll see the. That's it.
Is that
Wonderful.
it? Okay,
Perfect.
great.
Thank you.
Okay. Okay. So I'll just start at the top. So we've got what do you like most about being an engineer? I think the thing I like most is when you get to go to site. So you get to go to see the building you've designed, and it looks like what you designed, but it's always a lot bigger. And it's really exciting and scary to see that it's standing up, but it also makes you really proud. So then we've got a question. I do engineering with my dad. Did you do any with your dad? So that's a really good question, actually, because as I said, engineering is about solving problems. And I know when I was little, I didn't even know engineering existed till I was about 17. But I did things like we built shelves with my dad, or helped him paint the windows, or when we were on the beach, we'd try and dam the stream. And actually, all of those things are really good examples of what engineering is. But I just didn't know that was its name. So yeah, I guess I did. Yeah. So what was the hardest structure to build? So I guess the hardest structure I built, I guess probably the bridge, because it's over the river, so that makes it a bit more difficult. But in terms of the hardest structure I've designed that has been built, is definitely Tottenham, so the stadium, because it's so big and so complicated. There's so many different people involved. And you have to think really carefully about where you put the cranes and which bits you bring in at different times, because because it's in the middle of London, it's difficult to get to the site. So it's really logistical challenge as well as an engineering challenge. So then we've got, have you discovered any new skills being an engineer? So again, really good question. So I think people generally go into engineering because they like maths and science, but they want to do something a bit more in the real world. But actually, there's a lot of other skills required in engineering. So as I said at the start, we work with lots of different people. And I think the main thing since working, I guess, is I've improved sort of my communication skills and confidence in talking to different people about your job, including things like this, talking to kids and explaining what you do. So I think those skills are some that have improved a lot that I didn't expect to, because I expected to improve my technical maths and science ability, but I didn't expect that. What inspired you to do what you do? So I guess I didn't really know I wanted to do engineering, like I said, till I was 16 or 17. But when I started to think about what I liked, as I said, one of the things I really liked was building dams on beaches. And another thing I really liked was watching megastructures on TV and seeing how people manage to bring buildings to life. So I think, yeah, those two things really made me want to do that sort of thing. And then when I found out what engineering was, that was the perfect opportunity to be able to do it. So what structure took you the longest? Well, the project I was on for the most time was Tottenham. So I spent 3 years working on that. So that's quite a long time just working on one project. But it's so big and complicated that some people spent 10 years working on it. So definitely that one. Do you draw your designs on paper or do you use graphic design? So that's a really good question. So normally when we're starting to think of how we're going to do building at the very start, we work really closely with architects to work out what shape the building should be and how big it should be. And when we're doing those different ideas at the start, then we often draw that on paper, because I think that's the easiest way to try and explain your ideas. Because if you try and talk about them, or if you try and write it down in words, it's quite difficult. But a picture does paint 1,000 words. But then when we get later into our design, we start to use computers more to make a 3D model of it. So then we can use the 3D model, and we can get the architect's 3D model, and we can compare them and look whether it works together, and we can bring in the electrical engineer and the mechanical engineer's model, and we can see if everything works. So that's really good. And then also we can then give the model to the builder who's going to build it, so they can make sure that they get all the pieces right. So we use both. So another question: is it difficult being an engineer in a male-dominated industry? So the industry is definitely male-dominated, but it is changing. There's a lot more girls starting to be engineers. So I know now at my company, the graduate intake, so people coming in after university, it's 50% girls and 50% boys. So that's really good. I've never found it a challenge. I know when you become a bit more senior, it can be more difficult just because you have less role models. But it is, I think it's something you just get used to, because at university there are a lot more boys doing engineering, and then at work there are. So I don't really notice it anymore, and I don't really think I'm treated differently. So it's very good in that sense. If you had not been an engineer, what do you think you would have done instead? Well, I thought about being an architect, so that's quite similar to engineering. But otherwise, I'm not sure. I really like sport, so I do a lot of sport. So maybe a PE teacher. So another question: what is the most impressive thing you've built? So I think the most rewarding thing, the hardest thing, I think, in a lot of ways, was the sewage system in Tanzania, because I was in charge of working with lots of different people and bringing the community together, with the government and with the local university and with local charities. And actually we made such a difference to people's lives, and being able to have basic toilets. So I'd say for me, that was actually, although it might not be the biggest or the most complicated engineering design, I think that's the most impressive. What was your first project and what did you learn? So it's difficult to define what our first project is. I'd say it really was building dams on beaches, and without really even realizing there's so many different engineering principles involved. So to come up with, you'd have to figure out where the water might go first, so you make that bit stronger, and how wet or dry the sand was and how that affected the design. So yeah, all sorts. My first project in a design office was working on a school. So working with a more senior engineer and a technician who does the drawing, and seeing how, I guess, how design was done in an office was quite interesting. And yeah, I think the thing with engineering is you're always learning. So every project you learn so much from. What structure took the longest to finish? So I'd say that's Tottenham. So it started being built 4 years ago and it's still not finished. So a long time. How many countries have you visited through work? So England, obviously, China, Rwanda, Tanzania. So I think only 4. I've been to a lot of other countries for other things, but 4 for work. But I know a lot of the more senior people at work have been to so many different countries through work. So yeah, they've been everywhere. Has every project turned out the way you wanted it to? That's a really good question. So I think what your ideas are at the start always get changed because either the person who's paying changes their mind what they want, or you realize it can't be built, or the architect changes their mind. But I think the main thing is the initial vision. So what's the purpose of the building and what are we trying to achieve? I think that's always happened as I wanted at the end. I think the only one in Tanzania, I think we were, because it was so difficult, we were unsure if we were going to get anything built. So that actually turned out a lot better than I thought. What was your first experience in the workplace? So when I was 15, I did some work experience at a local architect's office, and I actually really enjoyed it. Yeah, work's a lot less scary and more interesting than I thought it was going to be. A lot more enjoyable. And again, just being able to work on things that were bringing a design to life was really exciting. But then I talked to two of the technicians in the architect's office, were more on the engineering side, and I talked to them a bit about what they did, and that bit actually more interested me. So that was really helpful in deciding what I wanted to do. What are the biggest challenges you faced as an engineer? So I think sometimes you have really difficult technical design, like how can you get something to stand up when it's really long, or it's really big, or it's really heavy. But I think actually bigger challenges are probably as you get more responsibility, you have to go to meetings on your own. So in Tanzania, I had to go and meet a minister from the government to persuade him to give us some money to be able to build a system. And you have to be able to explain your design to a non-engineer, and explain why it would be beneficial and worth the money. And I think often those things are actually quite challenging. But if you do it okay, and if they agree, then you get a lot of confidence from it. So that's really good. What's the biggest thing you built? So again, Tottenham would be the biggest thing that has been built from my design. What structure used the most materials? Definitely Tottenham. So it's huge. I know at one point it was pushing the price of electricians in London up because there were so many electricians working on it. If a child in a primary school wanted to be an engineer, what are your top tips? So I think the main thing about engineering is it's about being curious about the world around you and how things work. So I'd say work hard at school, and if you like maths and science and arts, like that's all good. That's really promising. But it's mainly just thinking about how things work, which actually we all do naturally. And I think probably primary school children would make really good engineers because they are interested in how things work. And it's only when we get older, I think we get a bit less excited about everything. So probably just keep doing what you're doing. What was your favourite structure? So one of my favourite structures I didn't talk about was we'd had a Christmas drinks party with the local architect's office, and we would design with them a sculpture out of cardboard. So it was about 2 pupils high, so probably like 4 meters high, maybe a bit bigger. And it was lit up from the inside, and then we made different shapes out of the cardboard with lots of different holes cut in it, and then it shone really nice patterns out. So again, it doesn't have to be a massive building to have a really interesting impact on people. What support did you need? I think when I was at school, obviously your teachers support you a lot in terms of learning things. I know I've been really lucky in all the different places I've worked. Everyone I've worked with has been really helpful, and I think that's a really good thing about the engineering industry, that everyone's so supportive and has time to help people out, even if they're really busy and important. And then also my parents, they've always encouraged me to do what I wanted to. And now engineering's more commonly known, but it was really rare to want to do engineering as a girl. And they really encouraged me to do what I wanted to, so that was really good. What's your favourite part of being an engineer? I think working with lots of different people, getting to travel and getting to see your designs come to life. What was it like working on the Spurs and Man City grounds? What did you do for each job? So for Spurs, for both projects, big projects have lots of engineers working on them. So we normally focus on one part. So for Spurs, I did the steel work. So all the steel that supports the east and the west stands. So that involves making sure it stands up, but also it's really interesting in football stands. Because the crowd jumps up when there's a goal or anything exciting, they all suddenly jump at once, and they might make the stand bounce. So you have to check whether it is designed strong enough to be able to take the bouncing. So that's really interesting, slightly different analysis you have to do. I did something similar on Man City as well. But I think the difference is on Spurs, I started working on it when there was a rough design in place. So I made the design more details, and then gave it to the builders, and then worked with the builders to make sure it was built on site. Whereas for Man City, I was working on the project at the very start. So there we were expanding the south stand, building a new stand on top. So I worked at the start to look at lots of different options, because it was on top of an existing building. It's more difficult, so you have to work out where you can put new columns and where you have to cut holes in the new building. Stadium are really interesting. Is the new stadium bigger than Old Trafford? So the new Spurs stadium is going to be 61,000 people, I think, and Old Trafford I think is like 70 or 80. So Old Trafford's definitely still bigger. But the difference with Old Trafford is because it's older, it was built in stands, whereas the new Spurs stadium will be all at once. Did you play with Lego when you were young, and does it help you to develop your engineering ideas? So I did play with Lego, but we had big Lego. I think it's called Duplo, so it's like bigger blocks. And we also had wooden blocks at home as well, so that's really fun. Like, see how big a tower you can build. It definitely helps to try out different things and work out what works. And again, it's all that engineering is actually just using maths and science to actually put numbers to things that you might think about anyway. So building a dam on the beach or building a tall tower, all of these things, it's just thinking about like naturally what works. So in the olden days, hundreds of years ago, when cathedrals were built, they didn't use maths. They used what they knew about how stone work and how forces flowed, but they didn't have computers to model it. They didn't do long equations. They use their intuition and their experience, which is still engineering. So yeah, I did play with Lego. What is the easiest part to your job? I think the easiest part is probably when you have to so if you've designed the building and you've worked out you need some beams, so you need some lengths of steel that span between columns to support the floor, and then you have to size them, because that's quite a standard thing to do. I think that's probably the easiest thing, but not when you first start doing it, but by now you've done it lots of times, so it's less challenging than everything else, I guess. How many structures did you build? Well, I don't know exactly. I've worked on quite a few different projects designing, in terms of physically building. So I built the university project, I built the bridge in Rwanda, and I built the sewage system in Tanzania. And I built lots of dams on beaches and lots of towers at home. So yeah, it depends what you count, I guess, because they're all structures. How long have you been an engineer? So I have been an engineer full time for 4 years. But I studied for 4 years at university first, and I worked in the summer, so did engineering then as well. How do you prevent injuries? I guess that probably means when we're building on site, which is a really good question. So health and safety has improved a lot in the past, say, 30 years. So on site, everyone has to wear a hard hat. So if something falls on your head, you're okay. And everyone has to wear a high vis jacket, so bright green. So if there's moving cranes, they can see you. And then there's barriers around sites, so where you can and can't go. So you don't go near a crane that's moving or heavy lift. And then there's lots of inventions that happen all the time to make it safer. So for example, builders have toolkits around their waist, and they have spanners and hammers and things in. But now, if they're working, say, 5 floors up, the spanner will have a little string that attaches it to the tool belt, so they can't drop it on somebody's head below because it will just stay attached to them. But I think a big thing on site is just using your common sense. So people plan the logistics of what activity is going to be happening when, to minimize risk. But it's also up to you to just be constantly looking around, making sure nothing's being lifted near you, making sure you're not standing on anything you shouldn't. Who was your role model when you were little? I don't know about when I was really little. I guess I like sports, so I there's lots of different role models like Jessica Ennis, the heptathlete, people who work hard and achieve what they want. In that sense, when I was a bit older, I guess when I watched Mega Structures, there's different architects and engineers on there that I thought were really cool. And then it's really sad, but I guess my parents, they've always worked hard and like instilled good values in me, and how, like, if you work hard, you can do what you want to do. And then when I was a bit older and I knew about different engineers, there's some really cool ones, loads actually. But one lady who is really good is, say, the Brooklyn Bridge in New York. Was built by the Washingtons. So originally the dad started designing it, and then he got ill, so his son took over, and then his son got ill. So his wife, who wasn't technically trained in those days, you weren't allowed to go to university as a woman. She helped to make sure the bridge kept being built when her husband was ill in bed and couldn't do anything. And without her, the bridge wouldn't have been built. So again, it shows like what determination can do. And actually, just because somebody says you can't do something doesn't mean you can't. What are you currently working on? So I'm currently working on a secondary school in Hackney. So yeah, so I've been looking at, there's a big sports hall. So because it's so long and lots of people are going to jump on it, again, it's bouncy. So a bit like with the sports stadium, you have to think about how we're going to stop it bouncing so much so people don't get worried. What has been your career highlight? I'd say there's 2. One is the sewage system in Tanzania. Getting that finished was amazing. Such hard work. I don't think I'll ever work as hard and think about something 24 hours a day. And then the second is standing on the stand in Spurs that we've designed. Yeah, really exciting and scary at the same time. What did you first think you were going to be when you were growing up? I guess, yeah, I'd always wanted to be in the Olympics, but that wasn't going to happen because I wasn't good enough. And then I think I didn't really know for ages and ages. And then I thought about being an architect, but then decided to be an engineer instead. Out of all the types of engineering, why did you choose structural engineering? So I chose structural engineering because it's quite different to mechanical engineering as a job, in the sense every project's different. So each time you get to work with the architect and the client, and lots of different people to help shape the building. And each project has completely different challenges. So at university, I actually really liked mechanical engineering. So I talk a lot about people bouncing and vibration and dynamics, and I've really enjoyed all of that sort of stuff. But I just didn't know what job there was out there to do that, and I think that's a big problem that I had at school and even at university. There's so many jobs in the world, and you just don't know about a lot of them. So I tried structural engineering, and I knew I really enjoyed it for all the different technical challenges, and getting to meet people and getting to travel and getting to see your building come to life. So that's why I chose structural engineering. Have you met anyone famous through work? I haven't met anyone famous. Not through work, I don't think, but I have worked on different projects. So I worked on a building that's just next to Kensington Palace in London. So that's for like the second richest man in the world or something. I got to go to watch Spurs a few times, so I guess get to see famous people, but didn't get to talk to them. But yeah, if as you get more senior, if you're in charge of a big project, you'll often get to meet the person working on it. So yeah, then you'll get to meet famous people, I guess. Where am I from? So I'm from Lincolnshire, so just north of London. So quite a small town. There was a big engineering factory near us that designed generators, so to make electricity. So I did actually do a project with them when I was 16 at school, and that was really interesting. That was such an amazing chance to get give engineering a go in a real context. So that was really good. Do you enjoy working on projects in different countries? Yeah, definitely. It's really interesting to see the different cultures. There's different challenges, different environments. So whether it's hot or cold, whether there's earthquakes, what the different rules in the different countries are. So yeah, it's just all different learning opportunities. What's the furthest place you've had to travel? So I think Rwanda was the hardest to get to, because I had to fly to Kenya and then change and fly to Rwanda. And then the roads there's not many tarmac roads, so it's lots of bumpy dirt tracks. So I think that's the furthest. That's most difficult, I guess. The furthest away was China. How many others work with you for each job? So that's a really good question. So it depends. So if it's a small job, it might be 2 or 3 structural engineers, then 2 or 3 mechanical engineers, 2 or 3 of everyone. But for Spurs, there was about 30 structural engineers and 30 mechanical engineers, etc. But then also there's all the builders involved. So there's like Spurs, there'll be probably like 10,000 people, I reckon, work on it in total, from the first idea of it to who pays money, the planners to make sure the council lets it be built, and then right at the end, the electricians and the plumbers and everyone who's helping with that. So loads of people. Do you earn much money? So engineers are fairly well paid. It's not as good as banking or lots of important jobs in the city. But the thing is, in England, people don't really understand what engineering is. So they think we're just fixing cars. So I think because we don't have the same status in society, we don't earn as much as, say, lawyers. But we still earn enough to live on and have a house and everything. What year did you become an engineer in? So it depends what you mean by that. So I started studying in 2010, started working full-time in 2014, and then I got chartered this year. So that means that I'm like a certain level, so I can go and be an engineer on my own. So yeah, did you always intend to be an engineer? No, not till I was about 16 or 17. Have you had any injuries through your job? No, I've only ever been injured playing sport. So yeah, because you have different protection when you're working. So if you're sensible, you shouldn't get injured. What machines do you need to build? So I don't really build machines, but for example, at university, when I did the shake testing, the earthquake testing, I had to build the frame that sat on the machine, and I had to program the machine to tell it how to shake, so how quickly to shake and how strongly. So I guess that's more like Yeah, a bit of programming, and there was a bit of building involved. But generally, structural engineering is using machines that have already been built to build something. If you can meet a famous engineer from the past, who would it be and why? So I guess Isambard Kingdom Brunel is one that everyone says because he was so great and he shaped so much of England that we still use today. So the Great Western Railway that goes from London to Bristol, different buildings along the way, tunnels. The Clifton Suspension Bridge was originally his idea, and then also Emily Roebling that I talked about from the Brooklyn Bridge, the lady who wasn't an engineer originally. How long did you work on the O2 project? So the O2 project is quite interesting. So we started on the Millennium Dome in like 1996 maybe, but I was 4 at the time, so I didn't work on it. And then we put the O2 Arena in the middle, so we had to somehow build a building under a tent. So that's really difficult. And then we've gradually built different shops and restaurants around it. So I've been working on things in the O2 for probably the past year, but more on the shops and restaurants and different entertainment inside, because I was too young to work on the original dome. Does the weather affect your work? So yeah, if you're outside on site, if it gets too cold, so if it goes below 4 degrees, it means the concrete won't set properly. So they have to stop work. And if it's too cold, the builders can't work either, so it has to stop. So you have to make sure when you're deciding how long something's going to take to build, you have to think about in winter when it might get really cold. So like last winter when it snowed a lot. How often do you travel abroad? I haven't been abroad very much with work, but that depends on what projects you're working on. So yeah, when I was on in Spurs, I was like up there, like I was living there, but then I'd come back to Bath a lot. So there's a lot of travel, but it was within England. When will the Spurs ground be finished? Good question. Who knows? The latest estimate is in the new year, so hopefully by then. But I'm not actually working on it at the moment because all the structure's finished. So now it's about the fit out, so putting all the bars in and the shops and finishing the wiring and things. Which structure used the least materials? So it's difficult to define that because if a building's smaller, obviously it uses less material. But there's also how much material it uses considering how big it is. So, for example, the bridge in Rwanda is quite efficient because it uses cables, which are really strong in tension. So if you try and pull a string, it's really hard to snap it if you pull it, but if you push it, so in compression, it just bends straight away. So in tension, it's really good. So by using cables in tension, the bridge is actually really light for how long it is. Do you speak any other languages? So I speak a bit of French. I did Spanish and Latin at school, and then I also studied Mandarin, so Chinese for a bit at uni, but I wouldn't say I was any good at any of them except French. Do you think people talking about their jobs will inspire people? Well, I think the main thing is when you, like I said, there's so many different jobs out there, and when you don't know about most of them, you definitely can't even try and do them because you don't know they exist. But if people at least explain to you what their job is, you can decide whether or not you like it or it's something that interests you, and then you can go and find more about it. And if you decide you don't like it, then that's good too, because you can know, well, that's not something I want to do. And it's just as important to know what you don't want to do as what you do want to do. I think that's all the questions. That's all the ones I can see.
Yeah, I think you're right. I think that's it. Does anyone have any more questions? Because there was, can I tell you, everybody, that there were some fantastic questions in that.
Yes, really good ones. Really
yeah,
good.
weren't there? And obviously some great answers, Ellie. Oh, here we go.
Oh, do you ever not enjoy being an engineer? Actually, surprisingly, no. Like, it amazes me every day that I'm not bored at work yet after 4 years, and that somebody's actually going to pay me to do this because I really like doing it anyway. So yeah, I think I'm really lucky. Like, I know most people, something about their job bores them, but yeah, I really like it.
Any other questions?
What's your favourite building? So one building I really like is the Burj Al Arab in Dubai. So it's slightly out into the sea, and they built a whole new island for it because they wanted it to be like really special because it was the first 7-star hotel in the world. And then it's shaped like a sail, so it looks like a boat in the sea, and then it's got an underwater restaurant. And it's got a helipad on the roof that Roger Federer and somebody played tennis on. So yeah, lots of different challenges, like building in the middle of the sea. It's windy out there and it gets really hot. So how do you do those things? And then there's a big atrium in the middle of it. So big open space, which makes it more difficult as well. Do you have any pets? No, I don't have any pets. Have you tried any other types of engineering? So when I was at school and I worked for the local company, that was mechanical engineering, which I did enjoy. But mechanical engineering, some jobs in mechanical engineering is more about so developing a product. So looking at a very small detail at one area of a product and seeing how you can make it better, which is really interesting. But I just thought I would rather look at more holistic things, so bigger things, and look at how things in a bigger scale fit together. And I think buildings affect your environment so much because they're all around you. So yeah, I just prefer buildings myself. Were your parents engineers? Interesting. So my dad did study mechanical engineering. Mechanical engineering, and he did that for a little bit, but he's not an engineer at the moment. But he actually discouraged me from doing engineering because I was a girl, which is really bad. But now he says he was just doing it to check I really wanted to do it and I wasn't just copying him. But yeah, so my dad was, but he unfortunately didn't initially encourage me to do engineering. But now he thinks it's great and he loves what I do. So yeah. What is your top tip to become an engineer? I'd say just work hard at school, maths and science especially, and just be curious about how things work around you, and get involved in stuff. How hard is it to make sure a structure will stand? It's pretty difficult. It's a lot more difficult than people think. That's why it takes 4 years at university and at least 4 years of working to be able to get chartered, so to get to a certain level. It also depends how difficult the structure is. So like if it's like a regular house, which isn't very big, because there's so many houses built, there's quite a standard way of doing that, so it's not too difficult. But if it's a more unusual structure like the Millennium Dome, there's not really anything like it around, so you have to design everything from scratch. How long did it take to build the bridge? In Rwanda, it took about 6 weeks in total, I think, because the charity builds a lot of bridges. They have kind of a standard way of doing it. So it's kind of like a kit of parts, but a big kit of parts. So it's a bit more simple in terms of logistics on site. What is the strongest type of bridge? Well, it totally depends on how big your span is, what it's carrying. So whether it's carrying traffic, whether it's just carrying people, and what its foundations are. So whether it's in the sea or whether it's over a gorge. I think for really long span bridges nowadays, tend to use cable stayed bridges. So that's when you have a flat deck, but then you have big towers and lots of cables coming out the towers to support the deck. So that's good for spanning a long way. But equally, there's quite over rivers in England. There's Roman bridges made of stone in an arch shape that have been there for about 2,000 years and still being used. So that's obviously really strong as well. So it just depends where you are.
Okay, so it's almost 11:30, and I think unless anyone has any other questions, I think we'll call it a day. Okay. Is everybody happy? It looks like we are.
Okay.
Right, so thank you very much, Ellie. That was wonderful. It was great. Brilliant.
Thank you very much for having me.
No. And if you don't mind, we'll have you back.
Okay. Yeah.
Yeah.
Good.
Great. Thank you. Okay. So thanks to everybody for participating in this event. So if you have any feedback, please do get in touch.
Yeah,
Oh,
and if you want to ask me anything else, feel free.
yeah,
Goodbye, Chris, I guess, but
yeah. If anyone does have any questions, other questions really that you think of later, do let me know, and I'll pass them on to her. Okay, so I'm going to end the meeting now, and so
okay,
thank you very
thanks.
much. Thank you.
Thanks.
Bye bye.
Bye.